Okay, so we're back here for part 2. We're on the back of the notes now. Now the inequalities get a little more complicated here on the back. Let's take number 8. And one thing I notice right away is we have variables on both sides. Okay. First thing we want to do is we always want to simplify each side if we can. Now on the left, that means we're going to distribute. So we'll have 4 times 5 is 20. And 4 times 3x is 12x greater than 7x minus 4. I like to get the variables on the same side. So I am going to move the 7x to the left side by subtracting it, minus 7x. So we get 20. This will be 5 plus 5x greater than, that's 0 minus 4, which is negative 4. So if the variable goes to the left side, the constant goes to the right. So we'll go minus 20. 5x is greater than negative 24. And then the last move is divide by 5, and we'll get a decimal, which is fine. We get x greater than, that would be negative 4.8, or negative 24 over 5. And if I want to make life a little easier, I can just say the set x such that. I can put that in there. Now one thing you'll notice is that I did not switch the symbol in my last move. You might say, wait a minute, we had a negative here, and I thought when we divided, we had to change the symbol. You only switch the symbol if you divide by a negative. We did not divide by a negative, we divided by positive 5. So that doesn't change anything. So the number line, we can go ahead and graph now. We have 0. X is greater than negative 4.8. So negative numbers are to the left of 0. Greater than is open. And we graph to the right. If we take, I'm going to go back to number 7 now. Draw the line down. The left side is okay. But the right side we need to distribute. We don't add first, we always multiply first, order of operations. So that would be 6 plus 10, and then minus 5x. We can combine like terms, the 6 and the 10 add up to 16, minus 5x. Now I would move the constant, the positive 16, by subtracting it. 25 is less than or equal to negative 5x. To undo multiplication, we're going to divide. In this case, we're dividing by a negative. When we divide by a negative, we have to switch the symbol. So that's greater than or equal to x. Now, we have to be careful here. I am going to rewrite this where the x is on the left side. I'm going to switch the sides. If negative 5 is greater than or equal to x, that means that x is less than or equal to negative 5. I switched the symbol because I switched the two sides. If I read this right to left, the alligator mouth is opening to negative 5. This is x less than or equal to negative 5. The alligator mouth opens to negative 5. So our solutions is the set of x's such that x is less than or equal to negative 5. The number line, here's 0, here's negative 5. Less than or equal to is closed because we include negative 5. Less than goes to the left. You're not wrong if you leave it this way, but the problem is that people tend to make mistakes then when they graph because they see greater than and they want to graph to the right. So I'll always put the variable to the left side. Now, number 9 and number 10. Draw the line down. 2x minus 3 less than. When you distribute, we get 2x minus 10. To move 2x, I'm going to subtract 2x from both sides. And we get, the x's get canceled on the left side. That's 0 minus 3, negative 3, less than. The x's get canceled on the right side, that's negative 10. So this is going to be a special case. Negative 3 is less than negative 10. Is that true or false? Well, on a number line, here's -3, here's -10. -3 is bigger than -10. That is not less than, that is a false statement. So what do we do in a false statement? Remember, with an equation, we said there's no solution to that. So in this case, if there's no solution, that means none of these values on the number line make this true, which means we leave the number line empty. We leave it blank. Okay, so there's no solution. As a set, we would actually graph a set with nothing in it. That is called an empty set. There's no values that make that true. The set is empty. Okay, so that's a special case where if it's false, then there's no solution to that. So the last one we'll do here in this section, number 10, x plus 6 greater than or equal to, distribute 2x plus 6, 2 times 3, minus 1x. Now on the right side, we have like terms. Let's combine those. 2x minus 1x is 1x. And you might notice, now we have the identical things left side, right side. Now I would subtract 1x from both sides, but again the x's will get canceled. 6 greater than or equal to 6. Now this time, that's true. 6 is equal to itself. In a true statement, remember that the answer was all the real numbers. Okay, or you could use the symbol, the double bar R, for the real numbers. So what would that look like on a number line? Well, if all the real numbers are answers, then the whole number line would be graphed, would be shaded. So the whole thing. This is no solution. Nothing makes this true. This is infinite solutions. Everything for x would make this true. And that is the end of part 2.